Sketch the vector v equals 1I minus radical 3j and find its magnitude. All right, so we know that the I and the j represent the components of the vector, right? I is called the horizontal component, and the j would be the vertical component of the vector. So really what this means is, right, you see the coefficient of I is 1. That means we essentially go to the right 1 unit. And then the coefficient of the j component is radical 3. That means we would just go down radical 3 units. Okay, so this is our vector. Now, we should note that a vector is a line segment. Okay, it is a line segment, so we do draw the line with the arrow pointing this way. Okay, it's not a point, as we've done with Cartesian and polar, right? So a vector is a line segment that has direction and magnitude. Okay. So then the question is, what is the length? What is the magnitude or the distance from its initial point here to the terminal point here? Okay, so we can use the formula. If you think about it really carefully, sort of, we're just using the Pythagorean theorem, right? This is 1, this is radical 3. So we can draw that triangle and get the magnitude, right? The magnitude usually denoted by double lines. Okay? Since it's a vector, I can't really show you this in bold, right? So because it's a vector, though, I do need to denote it is a vector, so we draw this little line above it, right? So then the magnitude of this vector will just be the square root of the coefficients, right? We call these a squared plus b squared. So a is the horizontal component, b would be the vertical component. So then the magnitude here would be 1 squared plus radical 3 or negative radical 3 squared. It doesn't really matter, right? So 1 squared is 1. Radical 3 squared is just 3. Right? So we get 2. So what does that mean? It means that the distance from the initial point to this terminal point here, right? The distance is going to be 2.